Section 2.3, problem solving using inequalities. So the objective here is to recognize word problems that have inequalities embedded in them. And what we're going to notice is that there are certain phrases that are key indicators. For example, let's take a look at some of these phrases. The first phrase would be at least. If it says at least this many, it means that that many or more. Okay, so that's going to be greater than or equal to. At least. At most. If it says at most this many, at most you could have 10 pencils. It means you have 10 pencils or less. So that would be less than or equal to. Then you have no more than. Well, if you can't have more than, say no more than 75, means you can have 75 or less. That's again less than or equal to. And no less than is greater than or equal to. That means you need to have, if you have no less than 7 of these, it means you need at least 7 or more. So that's going to be greater than or equal to. Now, at certain times, it's just going to be greater than or just less than, and we'll be able to identify those in the problems. So let's take a look at the first example. It says a store is charged $5.50 for calculators and a delivery charge of $25 for the entire order. If the store then sells the calculators for $8 each, how many must be ordered and sold to produce a profit of at least $86? So here's what I want to think about for this problem. Profit means you make more money than you spend. So your income is the amount of money you make. The money you spend is your cost. So if I make an income of like 70 bucks and my cost was say 20 bucks, that means my profit margin would be $50. So clearly it's going to be income minus cost. So what we can do here is we can say that profit is defined as income minus cost. Now, in this problem, we have to think about what our income function and what our cost function is. So we can start by saying, let x equal the number of calculators. Now, it's the same amount of calculators you buy and sell. The problem is assuming that you have no leftover inventory. So the income from each calculator is $8 per calculator. So income would be 8x. But the cost for each calculator is the issue now. We have to think about what the cost is. Well, each calculator costs $5.50, but there's a $25 surcharge for the order. So it's $5.50 per calculator for cost, but there's a $25 flat fee you have to pay for the shipping. So in this problem, we want our profit to be at least $86. So it could be 87, it could be 88, it could be 89, at least 86. So we want this to be greater than or equal to 86. At least 86. Let's go ahead and solve this now. If I look at this, I see the negative sign I have to distribute, so it's 8x minus 5.5x minus 25 greater than or equal to 86. I'll add the 25 over to the 86, making that 111, and at the same time, I'll combine the 8x minus the 5.5x, giving us 2.5x. And then here, if I simply divide by 2.5 on both sides, I'm going to get x has to be greater than or equal to 44.4. Well, at this point in time, we have to use logic and say, if you need greater than or equal to 44.4 calculators, you need at least 45 calculators. So your answer is at least 45 calculators. And again, that's the amount of calculators that you've purchased and sold, all of them. No inventory left over. It'd probably be a little more complicated if you had some leftover inventory, and then you would talk about price reduction and selling it cheaper to make up for that margin that you're missing. Example 2 says find 4 consecutive even integers whose sum is between 20 and 30. So what we want to do here is start with our let statement right away. Whenever we have these integer problems, start with a let statement. So let's let x equal the first even integer. If x is the first one, then x plus 2 is the second, x plus 4 is the next, and x plus 6 is the last. Because they're even, so they have to be different. They have to be different by a value of 2. Or there needs to be a gap of 2 between each of these integers, which is what's indicating the plus 2 for each of these successively. Now we want to know that the sum of these is between 20 and 30. Okay, between 20 and 30. It doesn't say inclusively, so it means that the sum of these is somewhere between 20 and 30. So that means we're going to use these symbols now, because it's between there. This is like a compound inequality with a conjunction, where we have to think about the overlapping of two sets. It has to be between these two endpoints. and it's the sum of them, so we need to write this. And what we do is we notice that we have 4 x's there, and then we combine our common constants. We're going to end up with a value of 12. So here's what we get for our inequality. Now, we can solve this by splitting it up, or we can actually go through this and subtract 12 from both sides at the same time. So let's subtract 12 from all parts of this equation. And what we get on the left-hand side here is going to be simply 8 less than 4x less than 18. Now what we're going to notice is that we have to divide by 4 in all 3 parts of the inequality, yielding 2 less than x less than 4.5. Well, it's confusing at first because the answer says we want to find an even integer, and x is our even integer, and it's at first tempted to say that your answer is 2, but it is not equal to 2, it's greater than 2. The only integer that's even, that's greater than 2 and less than 4.5 is 4. Again, the only integer in here is going to be 4. So x must be 4. So what are those 4 values? They're going to be 4, 6, 8, and 10. Again, going back to our let statement to come up with the 4 even integers. So example 3 says, during the first 20 miles of a 50-mile bike race, John's average speed was 25 miles an hour. What must his average speed to the nearest mile per hour be during the remainder of the race if he is to finish in less than 2.5 hours? So we want to think about this in 2 parts. Let's start by thinking about the first part of this problem as the first 20-mile leg of the race. And during that first 20-mile leg of the race, he goes at a speed of 25 miles per hour. So we have a distance of 20 miles and we have a speed of 25 miles per hour. Now we still have the other 30 miles left in this race, and we need to figure out what that rate is. We don't know the time it takes here, but we can clearly figure it out. We don't know anything about time here, but we know that the total time needs to be something less than 2.5 hours. So let's find the time in the first part. Maybe we can help ourselves with that in the second part. So in the first part, we have distance equals rate times time. Solving for time, we have distance over rate. We take our distance of 20 over the rate of 25. 20 over 25 is 0.8. So this is 0.8 hours. That's what the first leg of the race is. Well, if the whole thing has to be less than 2.5 hours, we can take this away from 2.5 to see what we're left with. And that tells us that we're left with 1.7 hours. And because we want it to be under 2.5 hours, we really need to be under 1.7 hours for this to be successful. So a minute ago, we looked over here and we defined time as distance over rate. So we know for this part of the problem that our distance over rate needs to be less than 1.7 hours. Well, the distance is given as 30. So in this problem, if you want to go ahead and plug in, that's fine. You can do that. You could solve by moving it around. We could put 30 over r is less than 1.7. Realizing that 1.7 is really over 1, we can switch the locations of our diagonals, as we talked about already, just flip-flop right here. And what we end up with for this part is going to be 30 over 1.7 is less than r. Well, what that turns out to be as a number is 17.64. So we end up getting 17.64 is less than r. Well, you would never say that, really. Read it the other way. Read it from right to left. R must be bigger than 17.64, which makes sense. Because to remain under a certain limit, you need to go above a certain speed. If you go faster than that speed, you'll still be below that limit of 1.7 hours. So in the second leg of the race, again, what we really need to do is travel at a rate of at least 17.64 miles per hour. So example 4 says, Katherine's second test score was 8 points higher than her first score. Her third score was an 88. If she had a B average, which is between 80 and 89 inclusively, for the 3 tests, what can you conclude about her first test score? So we know that her second test score was 8 higher than the first. So let's call her first test score X, which makes her second one X plus 8. And we know that her third test score is not anything but just 88. And we know that we want the average of those three scores to be between 80 and 89. This is a perfect SAT type problem because there's a common mistake that most people make on this problem. So let's go into this. We know that it's average. Average means add them up and divide by however many there are. So the average of these three quantities would be x plus 8 plus 88 all divided by 3. Now we're taking that average and we're saying that it's between 80 and 89 inclusively. So inclusively means include the endpoint, so we put less than or equal to. A lot of people forget to divide by 3 here, and they just add them up and put it between there. Now, on the next line, what we're going to do is realize that to get rid of this 3 here, we have to multiply, but we have to multiply everything by 3. When we multiply everything by 3, what we end up getting is 240 less than or equal to, and on the right-hand side, you're going to get 267. Now, when I multiply everything by 3, this 3 drops off right here, so that's gone, because I'm multiplying by 3 in all of the terms. And the numerator I can combine into 2x plus 96. Now, if I subtract 96 from all three parts of the combined inequality, I'm going to end up with 144 less than or equal to 2x less than or equal to 171. And now I can divide everything by 2 at this point and realize that I'm going to end up getting 72 less than or equal to x less than or equal to 85.5. So what we can say for this problem is that we conclude about her first test score. Her first test score was defined as x. So that means her first test score is between 72 and 85.5 inclusively. And since it's rounding, usually around on tests, we could say that it's between 72 and 85. Okay, because we wouldn't really use 85.5 there. So it's somewhere between those 2 points. So it could be 72, 73, 74, all the way up to 85. And here's your homework for this section from 2-3 and then some mixed review.